Okay, so let's share my screen first. Okay. So my slide is visible. Slide visible, eh?
Yep.
Yes, sir.
Okay. Okay. So please be concentrated. We are discuss some important concept about what is array and how array is accept, how it display, some problematic approach of the array. Okay. So let's see. So whenever you use your C program data types, there are different data types are there. Like see here, fundamental data types, derived data types, user defined data types. What are the fundamental data types are there? Like this integer, floating, character, double, and void. These are some fundamental data types. And what are the derived data types? That are pointers, function, and array. And the user defined data type are structure, union, and the enumeration. So these are some different data type are there. In generally, array is your derived data types. Okay, so C supports a derived data types. It's called array. Array is a fixed size and collection of data type of the same data type. Collection of the data items of the same data type. Let's see. I'm giving an example. Please wait 1 minute. Let's do it. Okay, so see, whenever I'm say I need a variable, okay, variable. So that you declare a variable. How to declare a variable? Variable declaration like this: data type integer x. Then what happen here? Whenever written integer x, so here a memory is reserved. The name is x. A memory is reserved and its name is x. It having some address. In the computer, a memory is reserved and its name is x and it also having some address. If I am saying how many bytes the memory is reserved, it depend upon your compiler. Okay, it depend upon your compiler. If it is a 16-bit compiler, then the memory reserved for integer is 2 bytes. If it is a 32-bit compiler, then it is 4 bytes. Okay, suppose you imagine it is a 32-bit compiler. That means the memory reserved here is 2000 to 2003. 4 byte. 2000, 2001, 2, 3. 4 byte will be reserved. Suppose I need another variable. Then what happen? Then you declare, suppose here, like this x1, x2, two variable are there. That means two variable is created. X1 is created. Memory is created with name. Another is created with name x1 and x2. Similarly, someone say I need three variable. Then what happen? We declare here x3. If I am say I need 100 variables, then what happen? You have to need declare 100 times x1, x2, x100. Now it is very difficult to manage all the variable. If you use 100 variable in a program, it is very difficult to remember the variable name also. So at that time, what happen? We use array. Whenever you need a same data type, okay, same data type means we need 100 variable of integer type or floating variable of integer type. Okay, collection of data item. It is a collection of data item of same type, of the same type. That means if you need here 100 variable, instead of declaring integer x1, integer x2 up to integer x100, we directly declare how we declare like this: integer x100, integer x100. Now it is a array. It is a integer array. Okay, size is what? 100. Okay, 100. Here it is the size. It is x, that is array name, and in bracket it is the size. Clear? Clear? So see here, C is a supported derived data type called array, and array is a fixed size collection of data item of the same data type. Next, some another definition also there, like it is a linear collection of data item of similar data type. It is a linear collection of data item of similar data type. As you already know, the similar data type are there, and it is a linear collection. Okay, continuous memory location are there, linear. Then it is also a linear homogeneous data structure. This is also called as linear homogeneous data structure. Array is also known as index or subscript variable. It is also known as index and subscript variable. Again, different type of the array is there: one dimensional, two dimensional, three dimensional. See here, this is one dimensional, it is two dimensional, it is three dimensional. In one dimensional, what happened? Only one direction is there, and two dimensional, two direction is there, x, y, and here x, y, z. It is a three dimensional. Similarly, n dimensional is also there. Okay, 1 to n. We can add any number of dimension, but here we only study 1 or 2D, one dimensional or 2D, how to declare, how to define, and how to use our array. So first start our one dimensional array. So I am already telling how to declare a array. So here the declaration of array is nothing but data type, array name, and size. Size should be always be an integer constant. Size should be always be a integer constant. Like see, integer salary 20. Salary is a array variable name, and 20 is the size. Here float norm 30. It's a floating array. Size is 30. See, when an array is declared, the computer reserves memory location for all the elements of an array at the time of the compilation. Hence, the size should be integer constant, but not a variable. If someone asks the question that why the array here size is integer, not a variable, because see, because whenever you declare a array, whenever I declare an array like integer x10, so what happen? The compiler reserve memory. Okay, the compiler reserve memory at the time of the compilation. It is one type of the static memory location. Okay, so that here integer is required, and the size is integer is required. At the time of the declaration, memory is reserved. 10, 1, 2, 3, 4, 5. In this way, 10 memory are reserved because size is 10 and the name of the array is x. So here see, array in C, what happened? The array, that this is the array variable name. If you return any name here, this is the array variable name, and whatever the bracket is there, this is called your index of the element. Okay, index of the element. Like this array 0, 1, 2, 3, 4, 5. So 0 is the first index, 1 is the second, in this way up to max minus 1 or size minus 1 is the last index. So here see, the first index should be accessed like this: array in bracket 0. This is the first element of the array. And how this store in the computer memory location? It is a store like contiguous memory location. In this way, index are so 0, 1, 2, 3, 4 up to 11. The memory address is like this. Okay, suppose each memory cell at the 4 byte. Then see here 2000, next is 2004, 2008, 2012, in this way, and these are some value. Clear? Or any doubt you can ask? See, if I return here a array, I am declaring a array, suppose, see, integer x 5. Now in the memory, see, memory is reserved and the starting is always 0. In the C++, the starting index is 0. After that 1, 2, 3, 4. That is the size minus 1. Okay, last index is the size minus 1. So the lower bound of the array is 0 and the upper bound of the array is size minus 1. What is the size here? Size is 5. So the upper bound is like 5 minus 1. That is 4. Okay. So lower bound of the array is 0 and upper bound of the array is 4. Then you can store any value. Suppose 1, 2, 3, 4, 5. These are some value are there. And suppose here the address are there. Suppose starting address is 1000 and each memory cell is reserved, suppose 4 byte. That means next address is 1004, next is 1008, 12, okay, 16. Starting address first is 1004, 100, 100, 1004, 1008, 1012, then 1016. Okay. So these are contiguous memory location. Got it? All of you got it or not? Okay. Next is C. Here is same. In C, the subscript index of an array element start from 0. And the index of the, already told, the index of the first element of array is called your lower bound. And the index of the last element of an array is called upper bound. Okay. So for the C and C++, the lower bound equal to 0 and upper bound equal to what? Size minus 1. So if you calculate the size of the array, so the formula is upper bound minus lower bound plus 1. That is the size of the array. If all the elements of an array are stored in the contiguous memory location. So here the formula is used, upper bound minus lower bound plus 1. So see, if I am telling here, in these cases, your upper bound is 4, lower bound is 0. If you calculate the size, see, that is your upper bound minus lower bound plus 1. So the total size is 5. Okay, upper bound minus lower bound plus 1. Okay, suppose I am telling if upper bound equal to 55. In a question, suppose asked like this, and lower bound equal to 25. Anyone tell me what is the size of an array? Just put the formula and tell me. बताओ. Easy. Upper bound minus lower bound plus 1. व्हाट हैपेंड, नॉट अंडरस्टूड और नॉट? 81 कैसे हो रहा है? लोअर बाउंड देखो, लोअर बाउंड देखो 55 and 25, upper bound equal to 55, lower bound equal to 25. What is the answer? अरे upper bound minus lower bound plus 1 कितना आ रहा है? 31. See, very simple. I am telling the upper bound equal to 55, lower bound equal to 25. Size equal to upper bound, size equal to your upper bound minus lower bound plus 1. That is upper bound minus lower bound equal to 30 plus 1. So size equal to 31. The RA size equal to 31. Already telling na, the formula is upper bound minus lower bound plus 1. Similarly, if I tell the upper bound of a RA, suppose is 9, suppose 99, and lower bound equal to 0, in this case what happen? Upper bound minus lower bound plus 1, that is your 99 minus 0 plus 1, that is your 100. So if the size is 100, in case of the CC++, the lower bound is start from 0 and upper bound is 99. For the RA, for the particular RA, the lower bound is start from 0, after that 1, 2, up to 99. So total 100 elements are there for the array. Okay, so next another interesting question. Array is declared. Okay, how to calculate the memory address of the array? How to calculate a memory address of the array? Suppose I am telling a array is there like this, minus 5 to 5 of elements. Each element occupies 2 memory cells. The starting location is 1000. What is the location address of A0? Let's say I am giving a question. See here. Suppose, just I am changing the question. See. Suppose I am telling the array is like this, 0 to 500. Elements are there. And each element occupy 2 byte memory cell. Each element occupy 2 byte memory cell. And if the starting address is 1000, then what is the address of A10? इस लोकेशन का एड्रेस क्या है? Can anyone guess क्या होगा?
Sir, 1020.
1020, right? Any other student got it or not?
1020, sir.
Yes, but see, it is a small. I written here 110, so you can easily calculate. But for big array, it is very difficult to calculate like this. If I am giving 5000, then I am asking about any value in between them. So that time a formula is used. You can directly put if the value, then you can get the answer. The formula is like this. Sometimes MCQ question भी आता है like this campus में, like this. The formula is your L0 plus I minus lower bound into C to find out the location of AI. Any location of AI, this is the formula. I am telling that. कैसे फॉर्मूला आया मैं बता रहा हूँ, प्लीज सी इट. See, there is a 4 case are there. Case 1, suppose A1, A2, A3 and A4. This is one array. Second case, the index is starting from A0, A1, A2 and A3. In the third case, suppose I am telling the index is starting from any random point A3, A4, A5, A6. All are four element are there. Here I am changing sub in index. And IB, here suppose I am telling it is a negative. If the index is starting from negative, A0 and A1. See, this is the 4 cases or 4 way you define a index. इंडेक्स कुछ भी हो सकता है, 0 से स्टार्ट हो सकता है, 1 से हो सकता है, एनी रैंडम नंबर से हो सकता है, नेगेटिव से भी हो सकता है. मगर लिसन, इन योर C++, index is always start from 0. C++ में इंडेक्स से 0 से स्टार्ट होता है. ओके, बट द फॉर्मूला इज ऑलवेज जनरलाइज. फॉर्मूला सब जनरलाइज होता है, तो इसीलिए कोई भी इंडेक्स हो फॉर्मूला वर्क होने चाहिए. सो लेट्स, दिस इज द 4 condition of your array. Index is starting from 1, index is 0, index is at random position or it is negative. So here suppose I am giving here address. Suppose the address here 10, 11, 12, 13. 10, 11, 12, 13. Okay, all the case address are suppose 10, 11, 12, 13. 10 से start हुआ, 13 से end for the address. So the case 1, see, okay, 1 minute. See, the case 1 what happens, suppose I am telling to find out location of A3. Here is 12. Suppose I am using the formula. How you using the formula? See, I am always starting index is given. Always starting address is given. Suppose here starting address is 10. Starting address is 10. So see, here I am adding 10, after that plus 2. Then it is given 12. Starting address is 10. Then 10 plus 2 is 12. Okay. Can I write this like this? 10 plus 3 minus 0. For the location A3. See, for the first cases, can I write this 3 minus 1? Then it given what? 12. So what is the 3 here? 3 is the current index here and 1 is the lower bound. 10 plus 3 minus 1. 3 is the current index and 1 is the lower bound. That means starting address, then current index, then lower bound, we find the address of the particular location, A3. Similarly, see, for the case 2, in the case 2, if I am say again, find out the location of A3 in the case 2. So here 10, 11, 12 and 13. Here again see 10 plus 3 minus 0. What is 3? 3 is the current index, 0 is the lower bound. So we got the address is 13. For the case 2. Similarly, for the case 3C, suppose I am calculating location of A6. Then how to got it location of A6C? 10 plus 6 minus 3. See, what is the 6? 6 is the current index, which location you have to find out, and 3 is the lower bound of this array. That is 6 minus 3 is 13. Here see A6 address is also 13. Similarly, case 4, if you calculate, see location of A0. For the case 4, here A0, 10, 11, 12, 13. If you calculate the address of A0, see it is 10 plus current index is 0 and lower bound is minus 2. Then the total is 12. So here see for the A0, 0 is what? The current index and minus 2 is the lower bound. For the A0 address is 12. Okay, so that is the formula we have to find out. If any index is given, we have to find out like this. So let's see another things. Now up to we have to find what? To find out the address, we have to add L0. Suppose this is the starting address plus I is the current index minus the lower bound. Okay, up to we have to find L0 is the starting address plus I is the current index, then LB is the lower bound. Next, see, suppose I have a array with that many elements. See, A3, A4, A5, A6. Here what happens, see, each element occupies 2 memory cells. Like this, 10, 11, 12, 13, 14, 16, 17, 15, 16, 17. Each element occupies 2 memory cells. So here suppose I am calculating the location of A6. See how to calculate the location of the A6. That is again same, base address 10 plus current index is 6 minus the lower bound. Lower bound is here 3. But it get the address C 13. But 13 is here. Now the formula is not work. So how the formula is work? See here again a constant is multiplied. That is 2. Why? Because each cell occupies 2 memory cell. Each element occupies 2 memory cell. That's why I am multiplying 2. Now see, it is 10. 6 minus 3 is 3 into 2 plus 6. That is 16. And the starting address of A6 is 16. Now our formula is what? L0 plus I minus lower bound into C. Into C. So now the formula is like that. L0 plus I minus lower bound into C. That is your address calculation formula. Okay. Now you have to remember just the formula, and if a question is asked, we can directly put it and find the result. See. For the particular question, see, it given your array like this, a minus 5 to 5 of index, and given the question is read like this. See, array having minus 5 to 5 of element, each element occupy 2 memory cell. Starting location given 1000. What is the location address of A0? Each element occupy the memory cell. Each element occupy 2 byte. Starting address is 1000 is given, and it asks what is the address of A0. Then we just put the formula. Formula is L0 plus I minus lower bound into C. Here what is L0? L0 is the starting address, that is 1000. What is I? I is the current location 0, which location you calculate. Then what is the lower bound? Lower bound C. Here it is minus 5 minus 5 into C. C is the 2. So now the address is here 1010. For the particular A0 location, the address is 1010. Here it is L0 1000, lower bound equal to minus 5, C equal to 2. So here L0 plus I minus lower bound into C. So the location of H0 equal to 10 plus 0 minus 5 into T, 2, that is 1010. And if you arrange this in manually, see here manually also, A minus 5, that is 2 byte memory. Next it is 2 byte memory. In this way for A0, see the starting address is 1010. Okay, but for the big array it is very difficult like this, so that you can directly put the formula and get the answer. Clear? Or any doubt you can ask. Clear or not? Student? Okay. So next see. Then how to accepting a array? As you know, for the accepting any element, we have to use what? We have to return printf, enter the element, then scanf, ampersand n, address is accepted. Similarly, from the accepting an array having number of element are there. It is a collection of the data item. That's why you go for a for loop. We use a for loop. See here, first is accepting the data, like printf, enter the number of the data. What is the size? Like scanf percentage d ampersand n. N is now the size. Now we take a for loop for I equal to 0, I less than n, I plus plus. Then printf, enter the value. Each value are accepted through the user. Ampersand normal. Each value are accepted. Similarly, printing the value for I equal to 0, I less than n, I plus plus. Printf xi. Using the for loop, we printed. Using the for loop, we accept each element, and using the for loop, we printed. Okay, let's see an example. I am just declaring a simple array and accepting and displaying it so that you can clear. अच्छा, ऑनलाइन कंपाइलर विजिबल हो रहा है तुम लोग को ऑनलाइन कंपाइलर?
Yes, sir. Yes, sir.
ओके, first header file is declared. Next, in the main, I'm declaring a array first. How to declare a array? It is a data type. Suppose we need a integer array. So I'm declaring integer num. Suppose 30. I'm giving a size. You can give in any size. 40. Actually, this is a static. Whenever giving 40 means the 40 memory will be reserved. And index start from 0 to lower bound is 0 and the higher bound is upper bound is 39. 0 to 39, then total is 40. So that is your integer array. Next, then whatever the variable you declare, we write later. Next, printf, enter और size accept करेंगे. Enter the number of elements of array. Okay, enter the number of elements of array. Then size को हम accept करेंगे. कैसे करेंगे? scanf %d comma %n. Now size is accepted through the user. Okay, now size is accepted through the user. Next, see, we can accept the individual element of the array. Now size is accepted. Now we accept the individual element of the array. So how to access? I'm written just printf. A statement is written printf. Enter the element of the array now. Enter the element of array. Okay. Now, if you accept individual element, so what happens? There's a n element is there here. Number of element is n is there. So that here we need a for loop. Here you need a for loop because n number of element are there. We can accepting each element. We need a scanf statement. So here n number of element is there. So that repeatedly use. That means we need a for loop that is I equal to 0. I less than n. I start होगा 0 to n. I plus plus. Inside the for loop, what happened? I accept the individual element. Scanf %t ampersand num I. Okay. So individual element is accepted. Now what happened? I print all the elements. How to print is same. I'm just written a printf statement. The elements of array are okay. Elements of the array. Now I'm printing n number of elements. N number of elements को print यदि करूँगा. Again we need a for loop. If you print a single element or single variable, what happens? We directly write it. So here n number of elements are there. We can repeatedly, if you print it, we need a for loop. So the for loop is same. I equal to 0, I less than n, I plus plus. Printf printf percentage d slash t comma num I. Okay, here percentage d slash t num I. Num I means the element. Here I equal to 0 to n. Okay, now I'm declaring whatever the element are there. I, one is I, another use is n. Now run the program. See, the first is enter the number of elements of array. Suppose I am given 5. Then enter the elements of the array. First size is given, then elements is given. Suppose I am giving the element 50, 150, 60, 65. Any element you can give in 5 element. 5 element we give in. After that, it print it. Just print it. The element of the array are 50, 60, 65, 70, and 75. This is a very simple program to accepting the element of the array and also displaying the element of the array. Clear? Okay. Next, see, if I initialize the array, you already know how to initialize the array through the user. Up to user, you accept the size of the array, then individual element. So you can accept also initialize of the array also like this. How to initialize here? Data type, array name, size, and list of value. Directly whenever you declare, you can also initialize. Here integer x10, 5, 2, 3 up to 4. Okay, in this way we also initialize. Means here the 10 elements is initialized here. Directly you can initialize. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 element is directly initialized. Similarly, if you written like this x10 and 4 element is given, means the number of initial value is less than the size. Here the initial value are there and size are there. Here number of initial value is 4 and size equal to 10. If the number of initial value is less than size, then the remaining elements will be 0. The remaining element will be 0. Similarly, if you written like this, if the number of element is greater than the size, then what happen? If the number of element is greater than the size, here size is 4, means 4 element is allowed. But here see, the element are 6. Here what happen? Here actually it give error or warning. It depend upon the compiler. Some compiler is giving error and some compiler is giving warning. Like excess elements in the array initializer. If the number of element is greater than the size, or if you omit the number of element, it by default take the number of element. If you omit like this in the second statement, then it by default take 4. Here size become the number of initial value. By default it will be take like this. Okay, so different cases are there. If you directly initialize like this, then different cases are there. If you omit, then it directly taken from it, or if you return initial value is less than the size, then remaining element are 0. If the element is more than the size, then warning or error will come. Clear? Okay. So see, program to input and display the element of, okay. Next program to compute the sum of set of 10 elements. Next program करेंगे how to calculate the sum of 10 elements. 10 elements है, so how to find out the sum of the 10 elements and print it. Let's see. पूरा डिलीट नहीं कर रहा हूँ, just modify करूँगा. Okay, here I am declaring a array num40. हम 10 कर देता हूं because here 10 element are there. Now I am declaring I for the for loop. Another suppose taking sum to storing the sum result and initialize to 0. Next is what happened. Similarly, we accept the array. How to accept the array? Using the for loop. Your size is given already in the question. Size is given means 10 element are there. So no need to enter the size. If size is not given, you can give in the enter the number of size or n will be accept. But here size is given. Then printf enter the element of the array. So instead of the n, then we give in what? 10. Because 10 element are there. Now scanf percentage d ampersand norm. So 10 element is accepted. Now if you add this 10 element, then what happen? Sum of the set of number, then again we take a for loop. We take a for loop. For copy कर रहा हूँ डायरेक्ट. Then inside this for loop, what happened? We add sum equal to sum plus norm I. Okay, sum equal to sum plus norm I. Sum is initialized to 0 and sum equal to sum plus norm I. Then suppose I am printing the array. Print the element of array. Each element is printed. After that, if you want, if you print the sum also, because here you need the sum of the set, sum of the set of number. So that I am printed the sum. Printf slash n the sum of elements equal to percentage d sum. The sum of the element equal to percentage d sum. Now see, I am just run the program. See. Here n is 10, so that we need 10. Okay, enter the element of the array. 10 element you can enter here. Suppose I am enter 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 element is enter. Oh, space चाहिए. We can giving a space character. 8, 9, any 10 element you can enter. After that, the array will be print 1, 2, 3, 4, 5, 6, 7, and the sum of the element is print, that is 55. So just a simple program to calculate sum of the element of an array using the for loop. Using the for loop. Okay. Next, see, very interesting. The question is like this. Suppose what are the definition? If you return integer a, integer star a, integer a10, integer star a10, that is star a10, again bracket or this. So what are the definition or what are the definition? So let's discuss these things. Okay. See. The first definition I think already know. Integer a. What is the means here? A memory is reserved. Okay, a memory is reserved at the variable declaration, integer variable declaration. A memory is reserved and the memory name is a variable, and we can assign any value to the memory. If you return a equal to 5, then 5 will be stored. That is just a variable declaration. Then now what is the next? Integer star a. Integer star a. What is the means? This is a pointer declaration. What is the pointer? Pointer is store the address of memory. Pointer is store the address of memory. So here if I am written star a, that is a pointer declaration. Okay, so here now it is a pointer. Now a is a pointer. It can store address of integer data type because it is a integer pointer. But here I am just declaring a pointer, not assign. Then after, suppose I am written here, another variable is there, suppose integer x. Suppose another variable I am declaring integer x. Then after I am declaring, I am assigning a to ampersand x. That means now a will be store address of the x. X is a variable. Here, suppose the address is 1000. Now a will be store the address of x. Now a will be store the address of x. This is a pointer declaration. Okay, if you only declare the pointer and not define, then what happen? Here it is called your dangling pointer. Pointer is declare but not define. If you only define the pointer and not assign any address, that pointer is called your dangling pointer. I'm just defining but not assign any value. Here. Next. Now next definition is your integer a10. What is integer a10? You already know. This is the array definition. If I am written like this, integer a10, this is nothing but a array. Array having what? 0, 1, 2, 3 up to 9. Okay, array having 0, 1, 2, 3 up to 9. Index start from 0 up to 9. This is your array declaration. Next, what is written? See, if it is star a10, what is the means? If it is star a10, see, if it is integer star a10. Here what happened? Integer star 18 means this is the array from 0 to 9. This is the array from 0 to 9. But each element of the array is a pointer. This is the array from 0 to 9 means 10. But each element of the array is a pointer. See, this is a 0, 1, 2 up to 9. Here each element is a pointer. Means store the address of integer variable. Each element store the address of integer variable. That is also called as array of 10 pointers. That is also called array of 10 pointers. Okay, that is also called array of 10 pointers. Array of 10 pointers. You have to remember, array of 10 pointers. Next, like this. If the bracket is given, then what happens? If just a bracket is given, see, if a bracket is given like this, integer star a and 10. Now it is what? Previous case array of 10 pointers. Now it is pointer to an array of 10 integer. It is a pointer to an array of 10 integer. Like this. An array is there. 0, 1, 2, up to 9. Now A is a pointer. A is a pointer. Store the initial address of this array. Suppose array address is 1000. So A store initial address of the array. हाँ
तो सर एरे का नाम क्या होगा?
हाँ टेल मी व्हाट इज द क्वेश्चन. array
एरे का नेम क्या होगा सर?
you can array you can access through the pointer through में access करेंगे. Okay, directly not access. Here see, if you access this array like this, A, this is the pointer plus 0 star. It nothing but एक के जगह पे 1000 रहेगा plus 0 that is 1000 and star that is value at 1000. that means 1000 में जो value होगा उसको हम access करेंगे, that is 10 suppose. Similarly if you return star a plus 1, that is nothing but 1000 plus 1, that means next memory location. Suppose it is 2, that is 1002. 1000 plus 1000 plus 1, that is pointer increment, it giving 1002 star. That means next memory location is what? Suppose value is 20. So next memory location is 20. So you can access like this. Through the pointer you can access. A is a pointer to an array 10 integer. This is called your pointer. This is called your pointer to an array. Pointer to an array of size 10 integer. Previous cases, it is array of 10 pointers. Now it is a pointer to an array of 10 integer. If you declare like this. Okay. So see the next is integer star a bracket is there. That is what? That is actually a pointer to a function. A pointer to a function and a function returns integer value. This is a pointer to a function and a function return to a integer value. After that assignment will done. Similarly, the last case integer star a, inside this integer star b3 and integer star c3. What is this? It is also pointer to a function. Okay, pointer to a function. Again, return type is also pointer. In previous case, return type is integer, but it is integer star. Integer star means again return type is pointer. Pointer is return again a integer pointer. And take two parameter. What are the parameter is there? See, the first is star b3. That is array of 3 pointers. Array of 3 pointers. Next is bracket c3. Here bracket is given. That is pointer to an array of 3 integer. Pointer to an array of 3 integer. Like this. For this definition. It is a what? It is a integer star f, and inside this two parameters there. That is integer star b3 and integer star c3. Okay, again I am telling C. This definition is like this. This is nothing but integer star star f, and inside this integer star b3 and integer star c in the bracket 3. So here what happened? So f is a function pointer or pointer to a function, and integer star means return type is a pointer also. Return type is also a integer pointer because it is integer star is written. It is a pointer to a function, and function is written a integer pointer. Again it take two parameters. What are the parameters are there? First parameter is what? It is array of 3 pointers. Means this is your b having 0 1 2, this array of 3 pointer, array of 3 pointer, and in third cases it is a pointer to an array of 3 integer. 3 integer are there, 0 1 2. A pointer is there, it store the address. This was address is 1000. Now C will be stored address 1000. Now stored like this. The first case, that is array of 3 pointers, and the second parameter is pointer to an array of 3 integer. Pointer to an array of 3 integer. So that is the definition. Now see. So whenever we discuss about the array with the pointer, in generally the base address of the array is the memory address of the first element. The base address is nothing but the memory address of the first element. That is, suppose your array is integer x5, x is nothing but the address of the first element. That is, x is ampersand x0. To declare a pointer to an array, we can make pointer point to the x0 elements. We can also declare what? A external pointer also. See, if you declare an array like this, the base address means x, the name of the array is nothing but address of the first element. The name of the array is nothing but address of the first element. X0 is the first element. This is the address of operator. So the name of the array nothing but the address of the first element. But someone say, if I declare any external pointer, then what happen? How to declare? The external pointer is declared like that, integer star ptr, and ptr is now stored what? Address of the first element. Or you can also write like this, ptr equal to x. Why? Because base address is the address of the first element. The name of the array is the base address, is the address of the first element. That means if you write ptr equal to ampersand x0, that is right. Or if you write ptr equal to x, that also right. Because now pointer is stored the address of the first element. Instead of the ampersand x0, we can also write x. Similarly, if you write ptr plus I, it gives the address of any element. If you written star ptr plus I, it giving the value of any element. See, if I have written like this, Okay, see, if I am written what ptr plus I, ptr is the first element of the or store the address, ptr plus I, it is nothing but your address of xi. In place of the I, you can give in 0, 1, 2 up to n. And if you return star ptr plus I, it is nothing but value of element xi. ptr plus I, it giving ampersand xi, that is address of the element, and star ptr plus I is nothing but xi, that is the value of the element. Okay, for the external pointer. So let's see, I'm giving an example. The same, write a program to compute the sum of the set of number using pointer. Now I am using the pointer to calculate the sum of the set of number. In the previous case, I am directly calculate. Now I am using a pointer to calculate this. See, the same example. The same example, here I am declaring a pointer. How to declare a pointer? Here I am declaring integer star ptr, suppose star ptr is already declared. Now pointer is declared. Now some variable I am declaring. Variable is same, integer I and sum. Now I'm assigning the pointer with the array. Okay, assigning the pointer with the array. That is ptr equal to num. Num is what? The name of the array or base address of array. Now I'm assigning the ptr with the num address. Now printf, enter the element of the array. Enter the number of elements of the array. Suppose size, I am accepting the size. And then percentage d ampersand n. Now size is accepted. Now the element is accepted. Enter the element of the array. Then I equal to 0 instead of the, here I am I 0 to I less than and I plus plus. Now see. Okay. So previously I am accepting for I equal to 0, I less than n, percentage d ampersand norm I. What is ampersand norm I? Address of each element. If you access this address using through the pointer, then how you can access? You can access like this. That is ptr plus I. I'm telling that ptr plus I is giving the address of the element and star ptr is give the value. Now instead of the ampersand norm I am written ptr plus I. And whenever the for loop is going on, that is 0, 1, 2 up to n, similarly I value will increment, that is ptr plus 0, ptr plus 1 up to n, your address will be accepted. ptr plus I means address of the element. Now, okay. Now the sum, for the sum I am written for I equal to 0, I less than n, I plus plus. Now see, then in the previous case I am written here what? Sum equal to sum plus norm I. Norm I is what? The array, each element. Instead of the norm I am just written what? How to get the address, how to get the value using the pointer, that is nothing but star ptr plus I. Nothing but star ptr. Sum equal to sum plus star ptr plus I. That is star ptr plus I meant value. Ptr plus I means address. Now using the pointer you can access I whenever I will be increases. Similarly ptr plus 0, ptr plus 1, the value will increases. Sum equal to sum plus star ptr plus I. Now sum will be print. Now the sum will be print. Okay. Now run the program.
Sir, we have to declare n.
Declare n. N also declare. Right. Very good. Okay. Any other declaration? I is already there. No. See, enter the number of elements. Suppose I'm entering 5 elements. Then elements 1, 2, 3. Any element you can enter 5 elements. Then see the sum will be print. Sum of the element equal to 15. That means using the pointer here you access. That is one changes is here. That is ptr plus I instead of star norm I, and another changes is star ptr plus I. That is instead of norm I. That is using the pointer. The same. So that is your array2 pointer. Similarly, see here for this particular array having element 2, 4, 5, 6, 2, 4, 6, 8, 22. It is nothing but A0, A1, A2, A3, A4. And this thing is also written like this. A plus 0, star A plus 0, star A plus 1, star A plus 2, star A plus 3, and star A plus 4. Why? Because A, I am already telling that A is what? A is name of the array, that is your base address of the array, or that is nothing but a pointer to an array. Okay, name of the array is also a pointer. So that if you return A plus 0 or star A plus 0, it giving the value. Star A plus 1, it giving the A1 value. Star A plus 2, it giving A2 value. Star A plus 3 giving A3 value. Star A plus 4 giving A4 value. Similarly, if you exclude the star, we return like this: A plus 1, A plus 2, A plus 3, A plus 4, it giving the address. If you return A or A plus 0, that is first address, the 0th index address. A plus 1, 1th index address. A plus 2, next this address. A plus 3, A plus 4. This giving the address. And if you add star A plus 0, then this is value. So your conclusion is that is star A plus n is identical to an. If you return star A plus n, it is identical to an. And if it is A plus n, that is the address of nth index for the array of pointer. Next, see array of function. So here what happened? An array can be passed to a function either by value or by address. We can pass either by value, or it possible that you can pass also by address. If we need to pass the value of some elements to a function, for pass by value, if you need to pass the value some elements, if you pass some elements, but if sometime if you pass whole array, to pass all the elements of an array to a function, we need pass by address. यदि कुछ एलिमेंट को पास करना है, 2 एलिमेंट की 3 एलिमेंट, देन पास बाय वैल्यू में जा सकते हैं. यदि होल array को पास करेंगे, देन हम एड्रेस पास करेंगे. So let's see, I'm giving an example for pass by value and pass by address. Okay, let's see, I'm giving an example pass by value and pass by address. Here I am written a small function. First pass by value. Okay, first I am showing you pass by value. Function name is void calculate. It is take 2 parameter, integer A, integer B, and in this function we just print it. Suppose I am taken integer sum, and now sum, integer sum, now sum equal to a plus b, sum equal to a plus b. Now here you can also print it or you can return also. Okay, if you first print करते हैं, print it sum equal to percentage d sum. तो sum को print कर दिए, sum equal to percentage d sum in the function. So in the main function now see, in the main function I am declaring a array. Okay, यहाँ पर हम directly declare करके initialize कर रहा हूँ. We can also declare to the user also. That means we can enter printf, enter the size. First size will be enter, then enter the each element. That also possible. मगर एक declaration ऐसे कर रहे हूँ, मैंने directly initialize here, declare and initialize like this. Suppose any value can give in, suppose 20, 12, next 65, next 70, next 55. 5 elements are there. Next, suppose I am calling a function calculate. And here I am passing 2 elements of the array. Pass by value 2 elements. Suppose I am passing x0 first element, next x3. Okay, 0, 1, 2, 3, fourth element. Similarly, suppose I am passing calculate x2 and x4, third element and fifth element. Here is the pass by value. Just हम array का value pass कर रहे हैं, and here the value are just add it and print it. Let's see. See the sum equal to 90, sum equal to 120. The result will come. Sum first case it is 90. See the 90, 0 and 3, that is 90, and 2 and 4, that is 120. Here also you can return also. Suppose someone say I am returning the value. How to return? Here I am just return sum. Sum को return कर सकते हो, sum. Then here we can access the value. Okay, यहाँ पर sum हम return किए, whatever it return, it store a value. It function is returned and it store into a variable sum. Suppose here sum 1 and here also suppose sum 2. Sum 1 and sum 2. Then whatever the return, then type is integer type. I'm also change the return type here, integer type. Then here print. Now यहाँ पर print करेंगे, main में print करेंगे. तो कैसे print करेंगे? The same. We can print the sum 1 and also print the sum 2. So the 2 variable declare कर देते हैं. Now declare it integer sum 1 and sum 2. Now see the same program is there. Just I am returning the value here, integer return type, and here print it. The program is same. The sum equal to 90 and sum equal to 120. Okay, यहाँ पर print हुआ at the main function. Sum equal to 90 and sum equal to 20. So this is your pass by value. This is your pass by value. we can pass any value of an array. Two value are passes. That is your pass by value. Similarly, if you say pass by address, तो कैसे होगा? Suppose the same program, see, a program to compute the sum of the set of number using array and function. माने array में जितना element है हम sum calculate करना है. That means we can pass whole array. So how it? We can pass whole array. See here, the program like this. If you pass whole array, here sum का logic लिखना पड़ेगा again, like this. Integer suppose s equal to 0, s and another I is there for loop, and take a for loop. For loop is what? I equal to 0, I less than n, I plus 2. Inside this, sum equal to sum plus xi. We can add the element sum equal to sum plus xi and then print it. S will be print or sum will be print, whatever the variable is there, you can print it. Here s is there, so just print it. S will be printed. I equal to 0, s equal to s plus I. Yeah. And then parameter what? Here I am taking two parameters, and one is the array, suppose x, another is size. That is the size. One is the array, whole array, another is size. Okay, suppose no return type is there. Right. Now in the main function, what happened? We accept the array. Okay, either you can accept through the user, it's okay. We can accept through the user. How to accept it? It accept like enter the number of elements, then size will be accepted, and enter the element of the array. We can access each element of the array, and here we can pass it. So how to pass it? See, for this particular case, I am calculate function. The name of the array is x. Here see, if you pass the address, the name of the array address. If you pass the address, that is whole array is passed. The name of the address is x. Here you pass the array x, then the size n. Okay, either you can access through the user, otherwise size will be also given like this. So suppose size is 1, 2, 3, 4, 5. Size is 5. You can directly pass it, or you can user through. You can also pass it through the user also. No need of this sum now. Now see. See, the sum is printed. The array sum is printed. Okay. So here x means I am passing the whole array. Address of means I am passing the whole array with size equal to 5. That is the pass by address in the second case. Pass by value and pass by address. Next, I am giving some tips like this. See.
Sir, time up, sir.
हो गया, एक ही स्लाइड रखिए देखो.
ठीक है सर, ठीक.
So see, this is the case like this. Suppose I equal to 3 and I am written norm equal to I plus 8. So what happened here? See, if it is a pre-increment and post-increment, first you see. In case of the post-increment, here first norm value is assigned, then I value will increment. See, I am again telling you, norm I plus equal to 8. Like this. Suppose it is like this, I equal to 3 and x I plus plus equal to any value, suppose 50, I equal to 3. If it is post increment, then what happen? First it is assigned, means x3 value is assigned to 50. After that I value will be increment, I equal to 4. First x value is assigned, then I value will increment. Another case, suppose x equal to plus I, that is pre-increment, equal to 50. In this cases what happen? First I will increment. Suppose I value is 3, I value is now 3 for the pre-increment. C, I value is now 3, then I will be increment to 4, then x4 equal to 50. So that is the difference, pre-increment and post-increment. Here is same, here I becomes 4 and norm equal to 80. Similarly, if norm I plus is after the norm I, here the index is not increment, the value will be increment. Here in case the norm 3 value will increment by 1. Whatever the norm 3 value are there, it increment to 1. Similarly, check for the output. Okay, I'm sharing the slide. So you have to check the output. So now your array is complete, like array to pointer and array to function, and the different concept. Okay, thank you. Now you can leave, no problem.
Thank you, sir.
Thank you.